Welcome to Mr. Chalk's Revision Tips. In this video, we will look at orbital motion, natural satellites and artificial satellites. Orbital motion occurs whenever an object is moving forward at the same time as being pulled by gravity towards another object. The forward velocity of an object combines with the acceleration due to gravity towards the other object. So when an object moves in a circle at constant speed, its direction is constantly changing. A change in direction causes a change in velocity. So this is because velocity is a vector quantity, so it has an associated direction as well as magnitude. A change in velocity results in acceleration, so an object moving in a circle is accelerating even though its speed may be constant. An object will only accelerate if the resultant force is acting on it. So for an object moving in a circle, this resultant force is the centripetal force that acts towards the middle of the circle. Gravitational attraction provides the centripetal force needed to keep planets and all types of satellites in orbit. So, for an object to remain in a steady circular orbit, it must be travelling at the right speed. So the diagram shows a satellite orbiting the Earth, and there are three possible outcomes. So if the satellite is moving too quickly, then the gravitational attraction between the Earth and the satellite will be too weak to keep it in orbit. If this is the case, the satellite will move off into space. If the satellite is moving too slowly, then the gravitational attraction will be too strong and the satellite will fall forwards towards the Earth. A stable orbit is one in which the satellite's speed is just right. It will not move off into space or spiral into the Earth, but will travel around it in a fixed path. So, a satellite in a circular orbit around the Earth. So the diagram shows the velocity of the satellite at different positions. So explain why the velocity of the satellite changes as it orbits Earth. So the key things to talk about is that gravity causes the satellite to accelerate and the acceleration causes a change in direction. When objects move in a circle at constant speed, its direction is constantly changing. A change in direction causes a change in velocity. So this is because the velocity is a vector quantity. It has an associated direction as well as a magnitude. A change in velocity results in acceleration, so an object moving in a circle is accelerating even though its speed may be constant. An object will only accelerate if the resultant force acts on it. So for an object moving in a circle, this resultant force is a centripetal force that acts towards the middle of the circle. Gravitational attraction provides the centripetal force needed to keep planets in orbit. The gravitational attraction between two objects decreases with distance. This means that the closer two objects are to each other, the stronger the force of gravity between them will be. If the force between them is greater, then the greater the acceleration will occur. The greater the acceleration, the greater the change in velocity. This causes the object to move faster. This means that the objects in small orbits travel faster than objects in large orbits. Polar orbits take satellites over the Earth's poles. The satellites travel very close to the Earth, so they must travel at very high speeds. A geostationary satellite takes about 24 hours to orbit the Earth, so that the satellite appears to remain at the same part of the sky when viewed from the ground. These orbits are much higher than polar orbits, so the satellites are travelling much more slowly.
Thanks for watching.